All right, it's Mr. Ryan again. We just finished talking about binomial squared factoring. Now we're going to talk about another special case of the product sum factoring. It's called a difference of squares. Okay, so this is called a difference of squares. You'll hear some people refer to it as a difference of perfect squares, but what you're going to see in this video is that it does not have to be perfect squares in order to use the difference of squares procedure. So I just call it a difference of squares. So here's a difference of squares. Let's say that we have x squared minus 9. Now, here's what I want you to notice. This does not have a middle term, right? So this does not, you think you're not going to factor this the way that you factor product sum. But let me show you something, and I'm going to show you how it actually is like those other factoring situations. We could write this as x squared plus 0x minus 9. See, it is the same. It is the same. It's just that the middle term that we normally see has a coefficient of 0. And what is 0 times x? Well, 0 times x is 0, right? Because anything times 0 is 0. And then so if this is 0, what's 0 minus 9? Well, that's negative 9. So this whole expression is just negative 9, which is why it's x squared minus 9. Okay, we don't write the middle part because it has a 0 as a coefficient. But let's ask a question. What two numbers multiply to negative 9, but they add up to 0? Well, first of all, because it's a negative 9, it must be a positive number and a negative number, right? Also, the only way that a positive and a negative number can add up to 0 is if they are the same whole number, the same absolute value. So what I mean by that is this: negative 13 and positive 13. If you add negative 13 plus positive 13, you get 0. How about negative 26 plus positive 26? Also 0. How about negative 3 plus positive 3? Also 0. Negative 7 plus positive 7? Also 0. So whenever you have basically the same absolute value, but then one of those numbers is positive and one of them is negative, so like negative 100 and positive 100, negative 43 and positive 43, negative 1 and positive 1, I think you get it. Whenever you have that, when you add them together, they'll cancel out to 0. So what we have here with this difference of squares is it has to be a situation. Again, we're going to have our double parentheses. We're going to have an x at the front of each one. It has to be two numbers that are the same, but one of them is positive and one of them is negative. Well, what two numbers that are the same multiply to equal 9? 3, right? So it's going to be x plus 3 and x minus 3. Because when we multiply positive 3 and negative 3, we get negative 9. When we add positive 3 and negative 3, we get 0, which accounts for the fact that there is no middle term. So that's what a difference of squares is. Basically, what you do is, with a difference of squares, is you just set up your two parentheses. You put an x in each one, you make one of them positive and one of them negative, and whatever the square root of this number is, that's what you put there. And there's your difference of squares. So why don't you try a couple of them yourself? What if it was x squared minus 36? Pause the video and try this one. Okay, so hopefully you remembered first to set up your parentheses like this, to put an x in front of each one, and then one of them is going to be positive and one of them is going to be negative. And then what's the square root of 36? 6. So it's x plus 6, x minus 6. We're done. Try another one. All right. Why don't you try, this is a good one. How about x squared minus 1? This one kind of throws people off, but it works the same way. It's a difference of squares. Go ahead and pause the video and try it. Okay, so let's set up our parentheses first, our two sets of parentheses. We know there's going to be an x at the beginning of each one. Okay, since it's minus here, we put a plus here and a minus here. And what's the square root of 1? 1, right? Okay, yeah, yes, it works exactly that way. It's exactly how it works because 1 times negative 1 is negative 1. And 1 plus negative 1 is 0. So even now, this is a very important one. This one comes up a lot in the math world. You have to know this one. This is a very important difference of squares. Okay? Let's try just a couple more here. Oh, so sometimes you can do a difference of squares where it has a number on the front. What if we had 25x squared minus 1? I know what you're saying. Oh, there's a number there. It's not a 1 now, so I can't do it anymore. Actually, you can. Let me show you what you would do. Again, you would set up your 2 sets of parentheses. And what you're going to do now is, in addition to putting an x here and here, you're also going to take the square root of this number. What's the square root of 25? Right, 5, right? So we're going to put a 5 here with the x, a 5 here with the x. We're going to put a plus here and then a minus here. And then what's the square root of 1? 1. So put a 1 here and a 1 here. Yep. And if you were to work this out, you would end up with 25x squared minus 1. I want you to try another one just like this. How about 9x squared minus 64? Why don't you try this one? Go ahead and pause the video and give it a shot. All right, so hopefully you put your parentheses like this. And then here, what's the square root of 9? 3, right? Okay, so we're going to put a 3 here and a 3 here. We've got 2 x's, right? An x there and an x there. Because we got the difference of squares thing here, we're going to have a minus and a plus. And it doesn't matter whether you put the plus over here or the minus over here. You can put the minus here and the plus here. It's fine. What's the square root of 64? 8, right? So it's 8. So our 2 factors are 3x minus 8 and 3x plus 8. One more example that I want to show you. Just one more. Well, maybe 2 more examples, but I want to show you one more trick. What if we had x squared minus 7? And I know what you're thinking. You're going to say, well, Mr. Ryan, that 7 is not a square. Therefore, we can't use difference of squares here. Wait a minute. Maybe it is a square. Actually, all numbers are squares. They are squares of their square roots. I know that sounds kind of weird, but I want you to consider something. Look at this. Isn't the square root of 3 times the square root of 3, doesn't that equal 3? Right? So the square root of 3 squared is equal to 3. So 3 actually is a square. It's just not a perfect square. It's not a square of a whole number square. It's a square of an irrational number. And we can do this in, actually, sorry, I should have said all non-negative values are squares. Sorry about that. We're in a college algebra class, but when you get in, when we eventually get to complex numbers, we're going to learn about squares of negative values. So check this out. So what would so what could we say about 7, right? If we do the procedure here, we can still do difference of squares on this, right? It's going to go like this. All right, so we're going to put our x here and our x here. One of them will be a positive and one of them will be a negative. Now, normally at this point, we would go to this number and we would say, well, what's the square root of that number, right? Well, that's exactly what we're going to do. We're going to say, what's the square root of that number, okay? What is the square root of 7? Well, the square root of 7 is the square root of 7. So we're going to put square root of 7, square root of 7, and we're done. And yes, it does work. That's exactly how it works. So now I want you to try one just like that. In fact, you could make one up yourself if you wanted to, but let me make one for you here. Let's say that we have x squared minus, well, I don't want to make it too difficult, x squared minus 19, okay? Why don't you pause the video and try this on your own? All right, so hopefully you remembered to set up your parentheses, 2 sets of parentheses. So it'd be an x in front of one, or an x in each one. One of them is going to be positive, one of them is going to be negative. And now what would we put here? We would put the square root of this number, which is the square root of 19. And the square root of 19 is the square root of 19. That's exactly how we're going to leave it. We're not going to put it in a calculator and get the approximated decimal value. We're just going to put in the square root of 19. And that's it. This is a difference of squares. You should try and make a few yourself, and you'll really, really understand it. Okay?